let us now talk about parallel lines. And parallel lines are lines that never intersect. So if I were to sketch a quick example of that, here is my y-axis, here is my x-axis, and if I drew two lines, for example, one going like that and one going like that, note that they're going to go on in both directions forever, and they will never cross or intersect. And so this, what I have drawn, is an example of two parallel lines. Now, the way that we think about them as in terms of slope is that parallel lines have the same slope. So anytime someone asks you, if they give you a line and they say, find a line that's parallel to this, just give them another line that has the exact same slope. If you don't believe me, let's go back to Desmos, this wonderful graphing utility, and let's plug in y equals negative 2/3 x minus 4, and then let's do another one, y equals negative 2/3 x plus 1. Notice that even as I zoom out, these lines will never intersect. At some point it'll look like they intersect because I just zoomed so far out that we're looking so far away, but trust me, they have the same slope, they will never intersect, so these two lines are parallel. All right, we've been talking a lot about lines. Now let's go on to graphing. Although we've talked a little bit about graphing, let's go more into depth about it. So let's start off with this definition. The roots or zeros of a function, those two words are constantly used interchangeably, so you might hear one or the other. The roots or zeros of a function f of x are the values of x that make our function equal to 0. These help us also figure out the x-intercepts, which are ordered pairs or points on the graph where the function crosses the x-axis. All right, so example 6 says find the zero or zeros, there could be multiple, and x-intercepts or x-intercept of the function g of x equals negative 1/2 x minus 7. So the way that we figure out what x value is going to make it 0, well, I mean, if nothing else, if you're not even sure how to go about this, you could like plug in values and just guess. Like, let's try g of 4. Do we think that's a 0? I don't know, maybe. Let's try it and see what happens. So if I plug in 4 into my x value, then I get negative 1/2 times 4 minus 7, which equals, well, let's see, negative 1/2 times 4 is negative 2 minus 7. That is equal to negative 9. So surely enough, that is not a 0 of this function g of x. Maybe let's try plugging in 0. Let's see if that works. So 0 will be a 0 or a root if we plug it in and then our output is 0. I don't think that's going to be the case, but who knows? Let's see. So negative 1 times 0, sorry, negative 1/2 times 0 is still 0, minus 7, so negative 7 is our output. That means that this is not a 0 and this is not a 0. So how do we go about finding our zeros? Well, it turns out that if you set your equation equal to 0, you can use algebra to solve for x. Cool stuff, right? Yeah, Mr. Kwan, that's cool stuff. Okay, let's move on. So we want to get x by itself. So I am going to add 7 to both sides. I'm sure you're asking yourself, Mr. Kwan, do you talk to yourself a lot? And I sure the heck do. All right, so now my equation reads 7 equals negative 1/2 times x. And the way that we're going to get x by itself is I'm going to multiply this side by the reciprocal, hey look, we used a word that we learned earlier today, so I'm also going to multiply -1/2 times, maybe I'll multiply it on this side, by, oops, I erased the negative sign. So I'm going to multiply by the reciprocal, which would be -2. And the right-hand side will be -14. And, sorry, the left-hand side will be -14. And then the right-hand side is just going to be x. So this is our final answer. So if you wanted to write that in a sentence, you could say our 0 is x equals -14. And just to make sure that it's in fact the case, let's plug it in and see what happens. So if I plug in -14 into my vending machine or into my function, then I get -1/2 times -14 minus 7. -1/2 times -14 is +7 minus 7. And look, it checks out because we get 0. Now, the second part of the question is, what is our x-intercept? And that is our ordered pair. So our x-coordinate is -14 and our y-coordinate is 0. So that is the second part of our final answer. Okay? All right, let's move on to our last example. Find the zeros or 0 and y-intercept of the function h of x equals x cubed minus 4.8x squared plus 11.7x plus 1. Whew, that is a mouthful. All right, so let's try doing it the same way that we did the other one. Let's set it equal to 0 and try to solve for x. Oh, goodness gracious. I have not even finished writing this equation out, but I already see a problem. Do you also see that problem? Well, if you don't, let me spell it out for you. So in our previous example, we were able to use algebra by getting this x value by itself. However, this equation is much more complicated because here we have x, but here we have x squared, and here we have x cubed. So how do we get x by itself? It is actually quite complicated, and so what we're going to end up doing is we are going to use a graphing utility. And if you want to use the TI-83 or TI-84 or the Texas Instrument app on your phone, that's totally fine. I will upload a video of someone else showing how to solve for the zeros or the roots using the Texas Instrument calculators, but I'm going to show you how to do this using Desmos. So let's go back here. I'm going to exit out of these equations, and I'm just going to type in the equation that we had there. It was, let's see, y equals x cubed minus 4.8 x squared plus 11.7x plus 1. Okay, so I'm going to make this all big again, and we are trying to find the values of this function, or the x values that make our function 0. So if you notice, if I zoom out, there's actually only one place where that happens, and it's at this point right here. And it's, again, try to make that connection. Notice that x-intercepts and the roots or the zeros are both related. And here we have the x-intercept being that value, -0.0826, 0. The 0 or the root of this function is just the x-coordinate of that. So remember that number, because I surely won't. Let's see. Okay, so our 0 or root is x equals, let's see if I can remember it, -0.0826. Was that the number? Oh, hey, I remembered it. Awesome. Okay, so that is our answer. We will learn to solve a little bit more complicated equations later in the class, but for now, something like this, we're going to need a graphing utility in order to figure out what x value makes the output 0. Okay, now be careful. This question or example is a little bit different than the previous one because this one is asking for the y-intercept. And this one's going to be a lot easier to solve than solving for the x-intercept because remember the y-intercept, if I made an input-output table, the y-intercept is the ordered pair where x equals 0 and we try to figure out what y is. So that's a lot easier actually. Let's see why. So if I plugged in 0 into our function, then we're going to get 0 cubed minus 4.8 times 0 squared plus 11.7 times 0 plus 1. And the reason that this is so much easier is because of the fact that 0 has this really nice property that when you multiply a number times 0, it's just 0. So this simplifies down to 0 minus 0 plus 0 plus 1. And if we simplify that, we are just left with 1. And so I put a question mark here, but this question mark is really equal to 1. So our y-intercept is the ordered pair 0, 1.